My name is Jasmine, and I'll be going over 2.1 sets and operations on sets. First, we will talk about a set collection of objects. An example would be A, 1, 2, 3. 2 is an element of A, given that 2 is inside of the set. And 4 will not be an element of A, given that 4 is not inside of a set. There are 3 different ways to define a set. The first one would be word description. The second one would be listing and braces. And the third one would be set builder notation, which we will go over. To define something by word description, you would just write something out like the set of even, natural numbers. And that will be how you define something by word description. To define something by listing, you just do the brackets, and then it's like 2, 4, 6, 8, and so on. And that's how you define by listing. And to do set builder notation, you would do something along the lines of this. So let's say the union is 1, 2, 3, all the way up to 10. And the set A is 1, 3, 5, 7, and 9. You make a diagram. FA is 1, 3, 5, 7, and 9. Therefore, these will already be out. So that only leaves us in the union for 2, 4, 6, 8, and 10. So now we are talking about a complement of set A, which looks like this. So if set A is 1, 3, 5, 7, and 9, the complement of set A is 2, 4, 6, 8, and 10, which is basically the opposite of set A. So now we talk about the subset. A is a subset of B, written A subset B, if and only if every element of A is also an element of B. You can draw that out like this, having this circle be B and this circle be A. That is how you do A subset B, because every element of A has to be an element of B. Therefore, A will be inside of B. Now we can talk about equals. A equals B if and only if every element of A is an element of B. Therefore, if A is 1 and 2 and B is 1 and 2, A equals B. So now let's talk about proper subsets. Proper subsets aren't equal to each other. Therefore, if A is 1 and 2 and B is 1 and 2, they're equal. But if A is 1, 3, and 5, and B is 1 and 5, then B is a proper subset of A, because even though it's not equal to A, given that it doesn't have the 3, it still has 2 of the same elements. So B is a proper subset of A. Now we talk about intersection with elements of sets. So if A intersects B, then X is an element of A and X is an element of B. So to draw that out, you'll have set A, set B, and since X will be an element of both, it will be in the middle. Therefore, A intersects B. So if you have set A equals 1, 5, 8, and 12, and then set B is 3, 5, 10, and 12, the intersection will be 5 and 12, given that 5 and 12 are in both sets. They intersect at 5 and 12. So we have 5 properties of set operations and relations: transitivity, commutativity, associativity, properties of the empty set, and distributive property. For transitivity of inclusion, if A subset B and B subset C, then A will also be a subset of C. For commutativity, if A union B equals B union A, then A intersects B equals B intersect A. And for associativity of union and intersect, if A union B union C equals A union B union C, then A intersects B intersect C equals A intersect B intersect C. So we have properties of the empty set. If A unions the empty set unions A, that will just be A. But if A intersects the empty set and the empty set intersects A, then that will just be the empty set. Last but not least, we have distributive property of union and intersection. If A union B intersects C equals A union B intersects A union C. And A intersects B union C equals A intersects B union A intersects C. Also something called attribute sets, which is what we use to help elementary kids with sets without having to go through the abstract level of things. Over some things. This problem says, decide whether the following statements asserting set relations are true or false. You can pause it to give time to think. But for A, it says set MIXEDUP is equal to BEINPUX. Now, is that statement true or false? Is the statement false because the sets do not contain the same elements? Is the statement true because the sets contain the same elements? Is it false because the two sets in the same element but the order does matter? Or the statement is true if at least one element is listed in both sets, the two sets are equal. Now, if you pay attention real close, this set has B, but this set does not have B. This set has E, and this set does not have N. For two sets to be equal, they have to have all the same elements. Therefore, this statement is false because the sets do not contain the same element. For the second example, it is choose the correct answer. 17 is a subset of set 13, 15, and 17. Is this statement true because A subset B means that every element of A is also an element of B? This statement true because every element in 17, namely 17 is in 13, 15, 17. This statement is false because A subset B, but A cannot be equal to B, and A is a proper subset of B. This statement is false because A subset B an example of an empty set. This statement is true. So you know that this statement is true because 17 can be a subset of 13, 15, and 17 given that 17 is inside of the set. We just have to figure out which true it is. Is this true because A subset B means that every element of A is also an element of B? But no, because every element of A is not in there. So this statement must be true because 17 is in there, just 17 and only 17. Part of this equation, you have 6, 12, and 19 is equal to 12, 19, and 6. If 2 plus 3 is 5, and 3 plus 2 is 5, you still get the same answer, but the order does not matter. So it's asking if these are still equal, even though they're in different orders, basically. So you already know that they're equal because they have the same numbers, but the order does not matter because at the end of the day, you get the same outcome. Therefore, the statement is true. The two sets are the same list of elements. Order does not matter. For this problem, you can pause it to write down so you can go along. It says, let U equal A, B, C, D, E, F, G, H, A equal A, D, E, F, H, B equal C, D, E, and C equal D, E, F. Locate all the 8 elements of U in 3-loop Venn diagram, and then list the elements in the following sets. So you just have to choose which one is correct, and we will get right to that. So once you have it all written down on what you need to know, take some time and try to figure out what goes where, and then we'll all come together and share our answers. All right, so starting off with A. A is in the whole union and is also in set A. Therefore, it will just be in the circle where A can only have it to itself. B is in U and only U. Therefore, B will be outside of the Venn diagram and in the set where only U can be. C is only in B and U. Therefore, it will be inside of only B because the whole thing is the union. So it will be in B, given that it doesn't have A or C in it. D is only in U and A and B and C. Therefore, it will be in the middle. Same with E. It will be in the middle because it has every single one of the set inside of it. F will be an A and C because it's in the union as well, and it will be an A and C. H will be in only A, given that it's only in U and A, and G will only be in G. Will only be in the union, given that it's the only one that has. With that being said, you come back to the computer, and B will be your final answer. On sets, in the results tab on My Lab and Mastering, you can go back to 2.1 and practice all of these, and it's like a miniature worksheet to give good practice in. They also have video lectures if you don't remember. So you go back and try all of these, and let's see how that goes. Thank you for coming.